given the information that we have, we know that stress X is equal to minus 70 megapascal. Stress Y is the stress direction that we are told to find. And we know that stress Z is equal to 0. So the other information that we have is also the shear XY is equal to shear YX, and it's sitting at 40 megapascal. And we know that the shear XZ is equal to shear ZX is equal to 0. And the shear YZ is equal to shear ZY is also equal to 0. And then we are also given that tau max, okay, is equal to 75 times 10 to the power 6 Pascal. And this can be in plane or out of plane. Okay, either one. And we know that the stress U, like what I've written earlier. Now, this is from material mechanical property. Okay. And from here, we know that normal stress U is equal to twice, right, of tau max, or tau max is equal to stress U divided by 2, right? So from here, we know that the maximum U stress is equal to 2 times by 75 times 10 to the power 6. So this is equal to 150 times 10 to the power 6 Pascal, plus or minus. Okay. Okay. So these are all the information that we are given. Okay. So we're going to find the two values of stress Y. So I'm going to show 4 different ways or 4 different answers. And why I'm going to show 4, because there are 4 possible ways of constructing the Mohr circle. Okay, 4 possibilities. And 2 of these possibilities correct. The other 2 is wrong. And I want you all to know why it is right and why it's wrong. Okay. Okay, let's start. So we're going to do 3D Mohr circle. Okay. So the maximum, I'm going to sketch now. So we have our normal stress. 2, 4, 6, 8, 10 is enough. Then we have our shearing stress. Let me string a bit. Oops. So this is our shear stress, normal stress, 0, 20, 40, 60, 80, 100, 120, 140, 160. Okay, and then we have negative 20, 40, 60, 80, 100, 120, 140, 160. I'm going to do more on the negative side. Okay. Bear with me. I do apologize for this. Okay, I think I'm okay. So let me rewrite this. Times 10 to the power 6. If there's any question, just ask me, okay? Don't keep quiet. Okay. So minus 180, 200, 220. Okay. Right. So let's construct the box. Okay. Oh, we still have shear 20, 40, 60, 80, 100, minus 20, minus 40, minus 60, minus 80, minus 100. Element rotate clockwise on shear at the top and anti-clockwise at the bottom. So let's draw the boundaries that the circle cannot exceed. Okay. So we know that the maximum compression or the maximum normal stresses are at plus or minus 150, and the shear is at 75. Let's draw that box. So this is about 75 and 150. Okay. So our Mohr circle, our 3D Mohr circle, okay, cannot exit this red box. If it does, the solution is wrong. Okay, right. So let's look at the first point, and that is minus 70. So I'm going to draw our minus 70 line. This is our minus 70 line. And then our shear given is 40. Okay, so our 40 line. And our the other 40 line. Okay. So we are aware that point X, so I'm going to label this point X, point Y, and this is our point Z. And our point X, the element is rotating in an anti-clockwise direction. Okay, so this is our point X. Okay, that's our point X. So we can also determine our or let's calculate where our stress average point are. Okay, so there are two possibilities, right? So what do I mean by that? So we are aware that, right, that the tau max which is also equal to the radius of the circle is equal to 75 megapascal. We know that. So we know that point X, right, from point X until the zero shear stress line, right? Let me sketch this out. Okay. We know that at this is just a sketch, wrong color. I'll use a different color. I'll use a pink. Okay, a light. So we know that if there's a certain distance here, right, this should be equal to 75 megapascal or 75, right? And over here, this will be our stress average. Okay, where is it now is very easy to calculate, right? As you can see, or the other stress average point Okay, so I just need to flip this across. Right. So the other stress average point can be over here also. There are two possibilities. One can be on the left and one can be on the right. Okay, so we are going to calculate this stress average point. And we know that the radius of the circle is what? 75. And we are aware that the height or the distance from here to here is equal to what? Is equal to 40. Right? So very simple math. As you can see, we're very simple math. So we are going to calculate our stress average 1 and 2. Okay, so it's equal to minus 70 plus or minus, right? We know it's 75 squared minus by 40 squared, right? So minus 70 plus or minus, so 75 squared minus by 40 squared, square root is equal to 63.443. So one of the normal stress value or average stress is minus 133.443 megapascal, and the other one is equal to minus 6.557. Okay, right? So we know where our stress value is. So let's construct, okay, of determine stress Y, right, with stress average equal to minus 133.443 megapascal. Okay. Okay. So we plan to use this circle over here. Okay, we plan to use this circle. So 133. Okay, so I'm going to construct the green. We're going to use this stress average line. Okay. So we are going to use this. So 120, 130. This is 150. So we were close. Okay. So this is our stress average line that we're going to use. Okay. And then we're going to sketch it across here. Okay. And as you can see, you guys are aware now we are in the what? In the outside the red box now. Okay. So this over here is our point O. Okay. We use that first. Okay. Just the first possibility to calculate over here. This is our stress Y or point Y. Okay, point Y. Okay. And we know that this answer is invalid because it's outside the what? It's outside this red box over here, right? It's outside this red box. This is our operating boundary. It's outside. When it's outside means it's not valid anymore. Okay. But I'm going to draw the complete 3D Mohr circle, right, to show you like, okay, why this is wrong. As you can already see that it's on the outside. So now if we were to calculate stress Y, right, with this, is equal to minus 133.443. And all you need to do, right, is just minus 63.443, right, which is this value over here, right? So 133.443 minus by 63.443, you get 196.886 minus 196.886 megapascal.